Hey, hello guys, welcome, Manakam, Vandanam, Namaskaram. Today we are going to see mathematics second lesson, not second lesson, fourth lesson. I think it's determinant. First lesson is relations and function, then it's inverse trigonometry, then it's matrix, then it's determinant. Okay, matrix is the base concept of determinants. If you don't know about matrix, if you don't know what is a matrix, then I will prefer you, or I would suggest start to learn first what is a matrix, then to come to this video. But I haven't uploaded a video based on matrix. So I will just give you a basic idea about what is a matrix. If you know, then you can just skip few seconds. A matrix is a rectangular array where you can actually arrange numbers in that rectangular array. It means that you can actually store numbers in it. This is what that rectangular array is, and you can actually store numbers in it like this, like 2, 3, 5, 6, 7, 8, 9, 10 and 11. See, this is what the rectangular array is, and then here is the place where I store number, and then the amount of numbers that I have stored there will be represented here. See, there are totally 3 rows and then 3 columns. So it will be written as 3 into 3. This is what a matrix is, and this rectangular array I have said, right? That is actually of many different types. It's actually of scalar matrix, it is identity matrix, it is null matrix, it is there is diagonal matrix. Then like this, there are a lot of types: column matrix, row matrix, upper triangle matrix, orthogonal matrix. Like this, there are not millions. There are lots of types. Okay. So that's what a matrix is. Now, what is a determinant? Determinant is a single value. Okay, determinant is a single value. It is just a single value. That means, for an example, let us take that. Let A matrix be. A matrix will be represented by an alphabet. Okay, by a capital alphabet. So here that capital is going to be A. Okay, so A alphabet. So A is equal to, I will be just inputting some numbers, and note that this determinant is there, right? That concept is applicable one and only to square matrix. What is a square matrix? Number of columns which is m should be equal to number of rows, which is n. So this is actually A matrix. So what is A matrix? A matrix is I'm going to consider a 3 by 3 matrix. So let it be 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 3 cross 3. Okay. So here, what is its determinant? As I said, that determinant is a single value. So matrix will be represented like this, but determinant will be represented like this. That means, see, this is what a matrix is. Matrix for an alphabet. If you are representing a matrix in terms of alphabet, then you need not to represent any other additional symbol with that alphabet. Just A is enough to represent a matrix. But when you are asking, when someone is asking what is the determinant of A matrix, then you can write it as just like this. Okay, like mod A. But it is not mod A. It can be represented like this, or it can be also said as like this also. You can actually write it as. So it is equal to this equal to. First, what you are going to take is you are going to select a column or a row. It can be any column or it can be any row. You are going to select a column or you are going to select a row. Since it's very common and it is very easy to select the first row, so I'm going to select the first row. So this is what that first row is going to be. So in this first row, what I'm going to do is I'm going to take the first element of this first row. So what is that first element of this first row? That is going to be 1. Okay, 1 is what? First element of first row. So 1 into, okay, so I've taken this 1, right? So I'm going to eliminate this first row and then this one. Okay, first row and first column I'm going to eliminate since I've taken 1. Then I'm having remaining these 4 elements. So what you're going to do is you're going to put 1 into or 1 modulus, okay, 1 modulus. Since for easy purpose, since you all have to understand, so since for easy purpose, I'm going to consider 2 into 2 itself, okay. So then it will be kind of easy. 3 into 3 we will see later. One, two, three, 4, 2 into 2. So determinant of A or mod A is equal to 1. Okay, see, what you have to do is you have to first multiply this 1 with this 4. Okay, first you have to multiply this 1 with this 4. So what you will be getting 1 into 4, which is going to be 4 only. Then you have to minus, okay, then you have to minus it. Then after minusing, you have to multiply this 3 with this 2, which is going to be 6, which is then minus 2. Okay. What if the same matrix, let me consider. Okay. Here instead of A, I'm going to keep it as A dash, and instead of 2, I'm going to keep it as minus 2. Then how will be the answer? So here also I'm going to actually multiply. I'm going to multiply this 1 with this 4. So it is going to be 1 into 4, which is going to be 4 itself. Then 4 itself. Then I'm going to subtract it. Okay, I'm going to subtract it and I'm going to multiply. Then I'm going to multiply this 3 with this minus 2, which is equal to 10. Okay, which is equal to 10. So this is what a 2 into 2, for a 2 into 2 ordered matrix, you have to find determinant, and this determinant is going to be 10. So this is what the value of determinant is going to be for a 2 into 2 matrix. Okay. And also note that this sign I have written right. It should be actually written like this. Here it has to be written like this one, like the modulus symbol. But it is not modulus, it is determinant symbol. It should be written like this. Okay. And also when you are proceeding to find the determinant value, like I'm proceeding to find a determinant of A, then the first step what you have to do is you have to convert this into determinant. Like how you have to remove this brackets. Okay, you have to remove this bracket and then this bracket and just put two parallel straight lines. Here also the same thing. Okay, like this you have to proceed it with. Now what we are going to do is we are going to see a 3 into 3, okay, 3 into 3 determinant. Before going into 3 into 3 determinant, we are going to check what is a cofactor and what is a minor. I'm giving you an advice that if you don't know what is a matrix, then this lesson is going to be dead hard. Not dead hard, it is actually very easy lesson, but I will suggest to know first what is a matrix, okay, because that is what the basic is. Now what is cofactor? So before cofactor, we will come with minor. So what is a minor? What is a cofactor? These two are kind of interlinked only. If you know minor, then cofactor will be very easy. Minor is going to be the determinant value. It is going to be the determinant value like this. If I'm considering this one, okay, a matrix like 1, 2, 3, 4, 5, 6, 7. Wait, I'll write it in a good way. Next concept is going to be minor. What is a minor in terms of normal day-to-day life? It means a person who is less than 18 years. Okay, any person who is less than 18 years will be set as minor. Any person who is more than 18 years will be set as major. I'm a minor. You are also a minor, most probably. So in mathematics, what is a minor? Minor is a value. It is just like determinant value, and it is found for mostly order of 3. Okay, those matrix which are having order 3. Like for an example, I'm going to consider a matrix like A11, A12, A13, then A21, A22, A23, A31, A32, and A33, which is having order 3 by 3. That's it. Very simple. Very simple. This is what the order is, and this is what that matrix is. Okay, let this matrix be A matrix itself. Okay. Now the minor, I have to find minor. Totally, how many elements are there? Those many minors will be there. The number of elements is equal to number of minors. It means, see here, first what you are going to do is I'm going to consider any one element. So since there are totally 9 elements, you have to find minor for every 9 elements. First I'm going to consider this one. This element, if I consider this element, then you will have to delete the first that particular element's row and that particular element's column. So this element is having this row, is in this row and in this column, right? So I'm going to delete that particular row and column, and then I'm going to consider remaining 4 elements. So A11 is equal to modulus of A22, A23, A32, and then A33. This is what you are going to write. So I have already said here how to do this determinant. If I do that, take A22 into A33 minus A23 into A32. Okay, A32. This is how it will be. So this is how I have done for A11. So you have to do for remaining 8 elements for A12, A13, A21, A22, A23, A31, A32 and A33. For all these elements you have to do like this only. So yeah, if you do like that, then you will be getting your minus. Okay, since it is based on variables, I cannot give you a definite single digit answer, but if it is based on numbers, then you can easily find answers. So this is what a minor is. Minor is a single value which is not having any sign. Okay, it may have positive sign or it may have negative sign, but we will not multiply it with -1 to the whole power of I plus j. You might say, why did I say this last sentence? I'll be saying, okay, so this is what a minor is. Just understand what is a minor. Minor should be done like this. That's it. Just delete all those English sentences that I've said after saying this. Next is cofactor. What is a cofactor? What is a cofactor? So I'm going to consider the same matrix, or yeah, A11, A12, A13, A21, A22, A23, A31, A32, A33 is like this. Okay, so what is going to be its cofactor? What is a cofactor? See, first you have to find the minor. And I've said I have to find a minor here itself. This is how you have to find a minor. Okay, so I'm going to take a minor of A11 itself, since I've already found that. A11 is equal to, so what it is going to be, A22, A33 minus A23 into A32. Like this it is going to be. So for a cofactor, what you are going to do is you are going to multiply it with -1 to the whole power of I plus j. See, this is what I value, this is what j value. Okay, so this I value to the whole power of this -1 to this I value plus this j value you have to add, and you have to multiply this this minor. So when you multiply, when you do like this, you will be getting your cofactor at last. Okay, so for cofactor alone, it is dependent upon their position. So its negative sign is dependent upon their position, or its sign itself is dependent upon their position. Always remember this one. Okay, so here is the shortcut trick. See, you cannot just find this cofactor each and every time, and you cannot just do it for each and every time. Yeah, as I've said that. So what you're going to do is you are going to use this. If they have asked, find the cofactor. First, what you are going to do, you are going to find the minor of every element. You can use your mind itself for calculating minors, but make sure that you don't do any mistake with it, or also pen and paper. Just do it in a very fast way. Then what you're going to do is you are going to multiply it with this matrix. Plus 1 plus 1 minus 1 plus 1. Here minus 1 plus 1 minus 1. Here minus 1 plus 1 and plus 1. Okay, so I've got this matrix. So that means, what does it mean? For an example, I'm going to consider a matrix. Okay, and also I'm going to take a matrix and also its cofactors. I'm searching for cofactors. Okay, so the matrix that I've got here is minus 1, minus 2, 3, 5, minus 6, 2, 1, minus 8 and 7. Okay, so let this be B matrix. Okay, so this is a matrix and this name of this matrix is going to be B here. Yeah, so I've got this matrix and this matrix is actually B. So its cofactors are going to be absolutely, first it's minor. First I'm going to check its minor. What are its minor? So first A value, A11 value is going to be minus 26. Then A12 value is going to be 33. A13 value is going to be minus 36. A21 value is going to be 10. Then A22 value is going to be minus 10. A23 value is going to be plus 10. Then A31 is going to be 14. This is minus 17. And at last it's going to be 16. Last it's going to be 16. Okay, so this is what minor is. Okay, so for minor, that's it. Like the value, like how what I've said, I'm going to do only for one sum. Okay, for minor. So for A11 I will be doing this is what A11 is. So A11, if I'm taking that and this I'm going to cancel. Okay, then I'm going to use minus 6, 2, minus 8 and 7, which means, okay, so now you have to do the determinant. Okay, now you have to find the determinant. Like how you are going to find, first you have to multiply this minus 6. Oh, sorry. Okay, so this minus 6 with 7. So which is going to be minus 42. Okay, then you have to subtract it and then you have to multiply it minus 8 and then plus 2. So which is going to be minus 16. So if you're adding minus 42 plus 16, which is equal to minus 26. Okay, so I've got this value for A11. So how will it be for A12? So for A12, what I'm going to do is, what is A12? A12 is going to be this and this. This 2 is what A12. So yeah, I'm going to delete that's column and that's row. So I'm going to get remaining these four elements. So A12 is going to be 5, 2, 1, 7 A12 is equal to this 5 into 7, which is going to be 35, minus this 2, this 1 into 2, which is 2, which is 33. Okay, 33. So this is what its minor is going to be. This is how you have to find the minor for every element. Now, how will you find the cofactor? I have given this table now. So here plus 1 is there. So what you have to do is this plus 1 and this minus 26 you have to multiply. That means you will be getting minus 26 only. Here minus 1 is there and you have to multiply this minus 1 with this 33. Okay, but remember, multiplying a matrix with another matrix is completely different. Here I am not multiplying this matrix with this matrix, I am just multiplying this particular element with this particular element. Do not get confused with that. Here plus 1 is there, here minus 36 is there, I am going to multiply these two. Then for cofactor I am saying, for minor, with this step itself it's completed. For cofactor, what you have to do is, you have to additionally multiply all these things. To this place you have to multiply plus, to this place you have to multiply negative sign, to this place plus, to this place minus, to this place plus, to this place minus, to this place plus, to this place minus, to this place plus. Like this, if you are multiplying to that each and every element, then at last you will be getting the cofactor. That's it. Very easy, right? Cofactor and minor. Okay. Now we will be finding the determinant for order of 3. Okay, order of 3 matrix we are going to find determinant. Okay, so for matrix, so now I'm going to find order 3. So matrix A is going to be A11, A12, A13, A21, A22, A23, A31, A32, like this one. It is going to be. So first I'm going to take first any one row, okay, or any one column. Since row is my favorite thing, I'm going to take a first row. Okay. Okay, so now we are going to find determinant. Just now I've eaten my dinner and then I've again come here. Okay, so now we are going to find the determinant of order 3. Okay, so now they have given a matrix and let this be that matrix, matrix A. So how will be the determinant of this matrix? It's going to be, first I'm going to select either a row or a column. Since I'm comfortable with row, I'll be going with row itself. So first I'm going to select this first row itself. So in this, I'm going to select the first element of this row, that is going to be A11. Okay, A11. So since I've taken A11, I have to delete that row and that column. This row and in this column. Remaining these 4 elements are there, right? So that alone I have to take and write. But instead of doing like that, what I'm going to do is, you have to take this element and you have to multiply that element's cofactor with this element itself. That means here I've taken this element and I have to multiply this element with its own cofactor, which is represented with capital A11. Okay, then plus. Okay, then plus small 1, that means the second element, and I have to multiply it with its own cofactor A12 plus A13. That means this element and then this element's cofactor, which is A13. Okay, A13. This is how it has to be done. This is how the cofactor should be. Okay. Now the cofactor formula. How will be the cofactor's formula? It is going to be cofactor. We know that is equal to minus 1 into I plus j into minor of that I and of that j. Minor of that I and of that j. Okay, so I plus a and into minor. Okay, that's it. Like that only has to be written. So I'm going to substitute this value here with respect to their own position. That means, see, here I value is 1 and j value is 1. Here I value is 1, j value is 2. Here I value is 1 and j value is 2. Here I value is 1 and j value is 3. Like that I'm going to put here. Okay, that means I'm going to substitute the values. So it's going to be a11 and then this value I'm going to substitute. That means minus 1 1 plus 1 into minor of 1 1 plus a 1 2 into minus 1 1 plus 2 into minor of 1 2 plus a 1 3 into minor of minus 1 into 1 plus 3 into minor of 1 3. So this is how this equation has to be. Don't worry, I'm going to say a shortcut because this method is very big. If you are going into this method now, then this method is going to be very big. Okay, so now we have done like this. Now 1 plus 1 is going to be 2. So that means minus 1 to the power of 2, which is equal to plus 1. Here it is going to be 3. So minus 1 to the whole power of 3, which is going to be minus 1 itself. Here it is going to be minus 1 and to the whole power of 4, which is going to be plus 1. So here it's going to be positive. A11 into M11 minus, since it is going to be 3, so that means minus 1 to the power of 3 is going to be minus 1 only. And that negative sign can be multiplied with this positive sign. So minus A12 M12. See, this is actually 1 plus 3, so that means it will be 4. So plus A13 and minor of 3. Okay, so like this I have written it. Okay, actually some second thoughts are going into my mind. I cannot bear them. It's all giving me some angry inside my mind. Okay, concentrate on it here. Okay, so I've got this equation now. Now minor, what is a minor? Here even I've given it. See, this is what the minor is. Okay, so I'm going to take and write in this format. In this format, I'm going to write here also. So that means A11 and minor 11. So minor 11. So that means for this element, what is going to be minor? These 4 elements are going to be its minor. Yes, right. So A22, A23, A32, A33 minus A12. So for this element, what its minor is going to be. So delete it. So that means remaining this and these elements will be its minor is going to be. So that means A21, A31, A23, A33 plus, okay, plus, so A13 and its minor. So that means delete it. Okay, so remaining these 4 elements. A21, A22, A31, A32. So this is how its minor is going to be. That's it. With this, it's all completed. Then if you want, you can write their determinant form. Then that's it. Very simple. It's all going to be done. Okay, so instead of doing like this from beginning, what you will be writing like this element and then you will be writing its this variable, then like this at all. If you are doing in your examination, then the time will run out like fishes. So what you are going to do is, I'm going to just do one sum. Then you will be getting an idea. So let it be A. So A is equal to 8 and then 9. So what it's the color combination is not satisfying. Yeah, we will take something complex. Okay, I need not to be that complex, but it need not be 1, 2, 3. 3 minus 1 minus 2, 0, 0 minus 1, and 3 minus 5, 0. Okay, so like this it is. Okay, this is what the matrix is. So how its determinant can be found? So first A matrix, A determinant, and yeah, 3 minus 1 minus 2 0 0 minus 1 3 minus 5 0. And here you need not to write the order. Here order you need not to write. What is order? The representation of how many rows and columns are there, that is what we will be saying as order, and that order you need not to represent in a determinant. Okay, so how we have to do? First you have to select one element. First you have to select either a row or a column. So first I'm going to select here this first row only. It's what I'm very much comfortable with. If you want, you can also select this. Okay, it will be giving you the same answer only, no matter what. If you're selecting this, or this, no matter what. Okay, I'll be giving you one such answer only. That answer will be same for every column or row. So 3. No. Okay, so first I'm going to select this one. Okay, this one. From this row, I'm going to select the first element, which is going to be 3 into. So I've taken 3. So that means I have to delete this and then I have to delete this. That means this is what I'll be having. Okay, so instead of writing like this, instead of writing like determinant 0 minus 1 minus 5 0 and then to do in your mind like that at all, just do by just seeing this matrix or this yes, just by looking at this matrix. So into 0 will be 0, and while multiplying itself you have to multiply it with a negative symbol only. Do not forget that. So minus 5 into minus 1 is going to be plus 5 only, but since while you are multiplying itself you have to put there a negative sign and you have to multiply, it will be there minus 5. Okay, and minus, here you have to put minus, always it is a constant only. Okay, so there you have to put minus. See, minus is what there here. Here also minus is what there. Why is there minus? Because their position, okay, it is actually 1 plus 2. Their position, their address, actually it is in the first row and in the second column. And the cofactor is actually minus 1 to the whole power of I plus j. I value is 1 and j value is 2. So when you are adding it will be 3. So minus 1 to the whole power of 3. So which is equal to minus 1. So you are multiplying it with that minor. So since it is minus 1, I will put there minus. Okay, so now I have taken this. Okay, so now what we are going to do? Now we are taking this next element of this first row, which is going to be minus 1 into. Okay, make sure that you put here also minus 1. Okay, so that means I'm going to delete this and then this, which is equal to, see, 0 minus, see, 3 into minus 1 is going to be minus 3 only, but since you are multiplying it with a negative sign, it is going to be plus 3. Okay, into here it is going to be plus, here it is going to be plus. Why it is plus there? Because their position is in such a way. See, here it is actually 1 3. 1 plus 3 is equal to 4. Okay, 1 plus 3 is equal to 4, so that is going to be positive. So here it is plus. So that means here I'm going to select this and this. So here I'm going to delete, since I've taken this element, so delete it. So minus 2 into this one, okay, which is going to be 0. Here also it is going to be 0. So 0 minus 0, which is going to be 0 only. This total term itself you can cancel out to 0. Okay, this total term itself can be cancelled out into 0, and this one is going to be minus 15, and then this one is going to be plus 3, which is equal to minus 12. Okay, so the value of the determinant of this matrix is going to be minus 12. looks pretty good. Okay, now next thing that we are going to discuss is, see, we have completed cofactor, we have completed order. So next is a property we are going to discuss. Since this total lesson is in this total lesson we are going to discuss only about, in this video we are going to discuss only the theory part. So I will be giving you shortcut tricks, theories, how to do sums. With that you can attend MCQs, sums, and also some sums we can see. No problem with it. Okay. See, this is a 1 mark question theory. 1 mark question theory. Okay, if you know this, I'm definitely sure if there is a examination, if there is an examination in determinants, there will be at least one 1 mark question from this theory, and if you know this theory, within seconds you can mark the answer. So what that theory is going to be? It's going to be determinant of Ka is equal to K to the power of n into A. Okay, this is what that is going to be. It's completely confusing, right? Wait. But it's kind of simple. I'm going to explain everything. First of all, we will see what's the actual difference. Okay, what is the difference between determinant, say Ka determinant and K determinant A. What is the difference between them? First, we will look at it. Just simple. Here, in this case, we are going to talk about in this case, you are going to find the determinant of Ka. That means, for an example, I'm going to take it as A, B, C and D is a matrix, and this matrix is equal to A. Let us keep it as it is equal to A. So, first you are going to multiply this matrix with the K. That means Ka, Kb, Kc and Kd is what its matrix. Now you are finding the determinant of it. Okay, now we are finding the determinant of it. In this case, okay, now in this next case, what we are going to do is, we are going to first find the determinant of A. That means, first you are going to find this determinant. Okay, so first I've got this. So first I'm going to find this determinant. Okay, this determinant is something that I'm going to find first. So if I'm finding, then okay, so what is determinant is going to be AD minus CB. Yeah. Now I'm going to multiply this determinant with K. Here, before finding determinant even, in this case, before finding determinant even, I'm going to multiply it with K. Then I'm going to find the determinant. Okay. Here I'm multiplying K with the matrix. Here I'm multiplying K with the determinant. That's the difference. Okay. Okay. Now let us see what is the value. What's the value going to be? They will be giving you in question that determinant of 2a, okay, is equal to what value? Okay, what value of k into determinant of what value of k into determinant of what value k into determinant. That means they have given you this 2a. Okay, that means 2a something. It is a matrix. Okay, 2a is a matrix. A is a matrix. With that they have multiplied 2. Okay, and now they have found the determinant. Next, actually I'm kind of getting my physics as English in touch, and also I'm getting my maths as English touch. Okay, I like it actually. Back to the topic. Here, what I'm going to do is, here actually they are asking with what number, if you multiply the determinant of A, will it satisfy this equation? They are asking us to find out the value of K. So what's the value of K going to be? Just think, okay? And they have also given you the order. Very important data is that the order. So now if the order is 3 by 3, okay, if the order is going to be order, your order, my order, Okay, its order is 3, then it's 2. Okay, so now there are 2 orders. Now this is what the order is. They have given it as 3 into 3 and 2 into, okay, actually it's only with square matrix, so I'm not writing it. I'm not writing 3 into 3, just 3, 2 into 2, just 2. Okay, so this is what they have given here. What they are going to do is, here the exact number that they have given, right, that you have to write. Okay, in this place of k, exact number that they have given, that you have to write. Here, what is the number? Here also 2 only they have given. See, 2 is what they have given. So that you have to write. And what order they have given, that you have to put as power. What order they have given, that you have to put as power. That is what this property is. If they have given modulus of 3a is equal to ka, and the order is 4. Okay, 4 into 4 is the order. Then what you will be doing? You are going to write it as 3 to the power of 4 into determinant of a. Okay, determinant of a. If I have said that as modulus, then sorry. Okay, so this is what this property is. Very, 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 very important, easy, time saving theory. I know I'm being like a cheapskate. I'm behaving like a cheapskate, saving the space in the board. Because I want to give as much data as possible. Next is area of triangle. Area of triangle, very simple. Area of triangle, okay. Then also if 3 points are collinear, then for that, okay, so 3 mark questions and for 5 mark questions they can ask you this question, so this space will be enough, I think. Will it be? It will be. It should be. Yeah, now it will be enough. Okay. Now I'm really behaving like a cheapskate. If 3 points are collinear, if 3 points are collinear, then how will you prove? They have given all the data. They have given their positions. That means their address. See, what is collinear? That means you are going to take 3 points, okay, and those 3 points are in a single line. This is x1, y1. This is x2, y2. This is x3, y3. Okay, y3. Like this, they have given this data. Okay, and this is going to be A, this is going to be B, and this is going to be C, and they have given all the data that are required. Now, how will you prove that these 3 points are collinear to each other? What is collinear? That means those 3 points are lying in the same line. Then we will be saying it as collinear. So, how will you prove it? It's going to be, here you are going to use this formula. You are going to use x1, y1, 1, x2, y2. Okay, I will be using different color. For diagram, I have used it. For this is okay. x1, y1, 1, x2, y2, 1, x3, y3, 1 is equal to 0. If all these 3 points are substituting, and if the determinant of this particular matrix is 0, then that is collinear. Then that is going to be collinear. If the determinant is 0, then that's it. Okay, and make sure that you are going to put 1 there. Okay, make sure that you are going to put there 1. Now, next is that area of a triangle. Area of triangle. That particular thought is coming into my mind constantly. I'm just very angry on myself. Okay, instead of me blabbering, we will come to the concepts. This is what the triangle is, and there are those 3 vertices. What is it going to be? x1, y1. It is going to be x2, y2. It's going to be x3, y3. So now you have got all these 3 points of this triangle, vertices of this triangle. So what formula you're going to use is, so area of triangle is equal to, this is LE. Okay, area of triangle is equal to 1 by 2 into modulus and the determinant symbol. Modulus and the determinant symbol. This is modulus, this is determinant, okay? Because area of a triangle, not only area of triangle, any area of any shape in this world is going to be always positive. Always remember that. And it's all something we know, so need not to remember. It's already in your brain. If it's not a problem, just you can remember it now. x1, y1, 1. x2, y2, 1. x3, y3, 1. Determinant, modulus, that's it. Determinant and modulus. You have got this. This is what the formula that you are asked to use. Me again behaving like a chipstick. I have to save some space for other concepts. Make sure that here is, see, here 1 by 2 is there, but in this formula there is no 1 by 2. That's the major difference. That's not the major difference, that is fundamentally the differences. Then actually the particular concept that I'm about to say is something that we already have studied in our straight line itself, okay, in our class 11th standard itself. But if you don't know, it's actually used for one question in our exercise. So if you don't know, you can just know it. That it's slope formula. y2 minus y1 x2 minus x1 is equal to y minus y1 by x minus x1. No. Okay, so this is what a slope formula is. Actually, it's a fun fact that this formula is also known as rise by run. Rise by run. Why it is known as rise by run? It is known as rise by run because if you're taking in a, in a graph, the y-axis and the x-axis, if you're taking it, this one represents run. This one represents rise. Okay, because you are rising upwards. That's what you'll be seeing as rise. And this one means run. You will be running in the horizontal way only, right? So that's what it's known as rise by run. Just a fun fact. Just now I've come to know by checking in Google. Actually, this formula isn't used. Another formula is used, but it's not there in Google. I've forgotten it. Instead of m, I think it's going to be, if I'm not mistaken, y minus y1 whole divided by x minus x1 is equal to y2 minus y1 whole divided by x2 minus x1. I think this is what the formula is. Yeah, this formula is correct. I have memory power. Okay, so we are doing great. Next is adjacent of A. Before that, we have to study transpose of A. I hope you all know multiplication of a matrix, because multiplication of matrix is a simple concept if you know. If you don't know, it's kind of tough concept to be taught. Yeah, it's kind of tough to teach, But if you know, it's very easy. It's very easy. Just all you have to do is you have to practice 5 sums, then remaining the 6th sum will be very easy for you. What is transpose of matrix? Because for adjacent matrix, adjacent A, adjacent of matrix, you have to know what is transpose of matrix. That is why I'm saying, actually I think it is in our matrix lesson itself. It means columns are converted into rows. Or you can also say as rows are converted into columns. Okay, this is the equilibrium symbol in chemistry, right? So I've used combined chemistry and mathematics. Macrochemistry. Okay. So it's actually very simple. For an example, I'm using this word very simple a lot. But for me, maths isn't easy. For me, maths isn't that simple. It's always hard for me. I'm not talented in maths. Really. A, B, C, D, E, G. Okay. So this is what the matrix is. Is equal to. That means the transpose. This symbol means transpose, or also some people use this dash as a symbol. Okay. That means, see, this is where the first row now. So this row should be written like this. Like this itself, you have to make it as a standing line. From sleeping line, it has to become as a standing line. From the horizontal line, it has to become as a vertical line. So this A will come here, then B will come here, C will come here, and this is there. Now that has to be written as in the second row has to be written as the second column. D, E, F, and this third row has to be written as the third column. G is adjacent of matrix. Think. It means you have to first find the cofactor of each and every element, and you have to transpose it. Then you have to transpose it. That's it. Then you will be getting this one. For an example, I can give you one great example. Here A matrix, it looks like is it. First I'll be teaching one shortcut, and also for determinant I'm having a few shortcuts, but those shortcuts will be put in shorts because I haven't put shorts for a long time, and also I will introduce it with this video if I can. Okay, so this is what that matrix is. 1, 2, 3, 4. First 4 natural numbers. 2 into 2 is for the matrix. So now I have to give the adjacent of A. Actually, it is not pronounced as adjacent of A. It is pronounced as adjoint of A. Sorry, not adjacent. It is adjoint of A. So adjacent means just nearby, just like that. It means adjacent. Okay, touching each other. That is what we'll be saying as adjacent in English. Adjoint is actually different in math. Okay, so first I'm going to find the cofactor of every element. So first, what is cofactor of 1? 1 is actually 1. This is 1, 2. This is 2, 1, and this is 2, 2. So here positive, negative, negative, positive. Okay. So first plus 4. Because I'm going to delete this and I'm going to delete this. It will be plus 4. Then for what this is going to be? For A11, it is going to be plus 4. Okay. Make sure of this, that this plus 4, it is not because here plus and here 4. It is because here plus and there is 4 here. Okay. It is not because here is 4, here is plus. It is because here is plus. So I have written here plus. Next is A12. So A12 is going to be this one. So A12 will be negative into. So this is 2 now. So delete this. It will be 3. Minus 3. Then A21 and then A22. So what is A21? This is what 21. It is going to be minus into 2, which is minus 2. Then A22 is going to be plus. So delete this. It is going to be 1. Okay. So if I put it here, adjoint of A is equal to. Now just put their values in their respective positions. 4, minus 3, minus 2, and 1. Now transpose it, which means 4, minus 3, minus 2, 1. This is what it actually means. it actually means. Okay, but instead of doing this much colloidal, instead of doing all these torches to this one, I will give you a shortcut like this. Every teacher would have said this, but even though I will be saying this like you have never heard it, and you have to act like you have never heard it. So what we are going to do is, you are going to swap the places, okay? This 1 is going to swap its place with this 4, okay? And the sign of this 3 and 2, the sign of this 3 and 2 is going to be changed. See, 3 is positive and there. See, you are not going to consider this negative and this negative. That also can be considered. But I'm saying that just look at this element. Okay, just look at this element. And look here at this element. Look at the element, not at their positional sign, that is because of their cofactor. Okay, look at these two elements. Here it is plus 3 and here also it's plus 2 now. So those two signs are going to be changed. So that is what, see, plus 3 is converted into minus 3, plus 2 is converted into minus 2. So this is how it is going to happen. So this is what it is for 2 into 2. So what about 3 into 3? For this itself I cannot stand. Let me try my level best to stand still. Because if I complete this determinants, that's it. This concept of these determinants are very easy. Matrix determinants are very easy. But for inverse trigonometry, for relations and functions, they are having lots of concepts to be discussed. So I'm going to consider this matrix. 1 minus 1 and 2, 2, 3, 5, minus 2, 0, 1, 3 into 3. So how its adjoint is going to be? How the adjoint is going to be? We have to first find cofactor of every element as said. See, it can be also done in your brain, but instead of doing in brain, if you're doing in the paper, the mistakes will be reduced, and also you will be getting mark. Okay, do not do anything in your brain, do or show that in your paper. Then only marks will be coming in the paper. I'm talking like a person who gets very good marks in all the subjects, but I'm not. I don't know why. All I can do is to do hard work. Okay, so A11 is that I've already put here, so I'm going to just copy it. A12 is minus 12. A13 is going to be 6. A21 is going to be 1. A22 is going to be 5. Okay, just only one I'm going to do and show, then other than that, it's all easy, right? So A23, other than that, it's all easy, right? So A23 alone I'm going to do and show. So what is 2, 3? This element is what 2, 3 is. So delete this. Okay, so it's cofactor. So cofactor now, it is 2 plus 3. See, minus 1, add these two. 2 plus 3 into, okay, so what are these remaining elements? This and this deleted. So 1 minus 1 minus 2 and 0. Actually, you need not to do like this, just you can multiply here itself, but since you all have to understand, I'm saying, so this will be 0 and this will be minus 2 only, because when you are multiplying itself, there should be negative sign. So minus 2 into minus 1 is going to be plus 2, and when negative sign is multiplied with it, it is going to be minus 2 only. Okay, see. So 2, 3, see, it's actually here minus 1, okay, because it's 5, and here also it's a minus 2, which means it is equal to plus 2. It's equal to plus 2. So like this only it has to be done. Actually, every time I copy something from my note, whatever I'm getting is into my mind is myself when I was in 9th standard. I wasn't able to understand anything that was taught by teachers. I was getting fail marks. So that is why I'm trying my level best to give as much as possible. Is equal to, so 3-1 is going to be minus 11, and 3-2 is going to be minus 1, and it's going to be plus 5. That's it. So I've got all these elements. So instead of writing them in their positional order, that means instead of writing this here, this 3 here, wait, this 3 here, this 2, 1, minus 2, and here, this here, and this is there, this is there, and this is there. Like this, instead of writing them, you can write it as, right, like this. See, 3 right here, minus 12 right here itself, 6 right here. Then start from here. 1, 5, then 2 here, minus 11, minus 1, 5. Right, like this. If you're writing now, then that's it. What is that? Adjoint is ready. That's it. Adjoint is ready. Hot and sweet. Bloody sweet. So it's ready. That's it. It's something that you have got. Okay, very simple. So adjoint you have got. Next one major concept is A inverse. Okay, A inverse, system of equations. Yeah, A inverse, system of equations. I have no idea how I'm going to teach this. Okay, but first I'm going to teach this, and I'm going to teach, wait. Okay, first we are going to look at some concepts. And I've said one thing wrongly, that I'm not teaching anything. I'm just giving seminars. Okay, because I'm not a teacher to teach. And even if you ask me, I once are just listening to this lecture. You can go and listen to someone who has studied their degree as mathematics. Okay, I have not completed even a single degree. All I've written is 1 10th board examination, and even in that I've got 2 low marks. I'm not at all satisfied. 455 got. You might say it's pretty good marks, but I'm not satisfied. Okay, instead of having some boom and effects, we will come here. So there are equations. See, system of equations. Even in last year itself, we have seen the system of linear inequalities. That means they will be giving you system of linear inequalities like 5x plus 2 is greater than 2x plus 3. Like this it all will be now. So where you are combining 2 linear inequalities, right? Like that it will be, right? So like this, here I'm combining equations. Okay, equations. It can be equations of 2 variables. It can be equations of 3 variables. But when you are combining all those equations, you will be getting a matrix. And from that matrix, you will be able to solve the value of x, y and z. X, y and z. For an example, it can be, what example? Okay, I've directly jumped to one place. It's okay, even though I've directly jumped here. It's kind of worth it, I think. I know A inverse is there. We will check first this and we will come to A inverse. System of, what is it actually? System of linear equations. Instead of doing it with the standard form, I'm just going to give you one example and I'm going to say, and this time example is going to be 2 cross 2, so it's not going to be 3 cross 3. 3 cross 3 is just similar as 2 cross 2. If you know 2 cross 2, then 3 cross 3 is very easy. Wait. I'll check for 3 cross 3 itself. If I get a 3 cross 3, then we'll be getting a very good idea. No, I didn't get. So 2 cross 2 itself you will end up. But the standard form they have given is 3 cross 2 only. So, okay, first we will come with the standard form. Then we will be going with the example, so that this will be very clear. There are these 3 equations. A1, x1 plus b1, y1 plus c1, z1 is equal to d1. A2, x2 plus b2, y2 plus c2, z2 is equal to d2. A3, x3 plus b3, y3 plus c3, Z3 is equal to D3. Okay, so like this they have given you three different equations. What you are going to see here, A1, A2, A3, B1, B2, B3, C1, C2, C3, all these are constants. Just like D1, D2, D3, all just like that, all these are constants. So all these constants has to be summed into one matrix. That means A1, B1, C1, A2, B2, C2, A3, B3, C3 is equal to D1, D2, D3. Okay, just like this it's going to be. So there are three different matrices and you are going to name all these three different matrices. This matrix is going to be A matrix. This matrix is going to be X matrix. This matrix is going to be B matrix. Okay, it's A, it's B and it's X. So AX is equal to B. This is what the condition is. AX is actually going to be equal to B. Now what we have to do is we have to find these variables X, Y and Z, the X value. Okay, these variables we have to find. So multiplying it with the A inverse, that means if I take this A to this side, okay, if I take this A to that side, then automatically I will be getting X. So that means multiplying. Wow, very nice handwriting. Okay, with the A inverse, that means A into A inverse X is equal to B. Okay, so this total is going to be I. So it's going to be I, and here it's going to be A inverse. So I X is equal to B A inverse. If you don't know something like A into A inverse is equal to I, this is what the identity is. Okay, if you don't know, then you can learn it now. Since normally I'm not good in remembering things, that too, this is the first time I think you will be seeing this video. So most probably you will not know. So you can know this. Okay, it has taken me a long time to remember these sorts of silly equations. Okay, so it's going to be C, and also any matrix multiplied with I is also equal to that particular matrix. So it's going to be X is equal to B A inverse. So that's it. Like this only you have to find X. Okay, so since you are following this YouTube channel, I'm going to give you some tips and tricks here also, so you can easily find. You need not to waste your time actually. Here what you are going to do is you are going to check out first 3. I forgot to say one thing very important. What is singular matrix and what is non-singular matrix? Matrix or determinant? And I'll accept any. Non-singular and singular matrix. What is singular matrix? Singular matrix is where a determinant is 0. Non-singular is where determinant will not be equal to 0. Okay, so is there space here? singular matrix. If a matrix determinant, if a matrix determinant is actually equal to 0, then it is known as singular matrix. Okay, and if that matrix determinant is not equal to 0, then that is known as non-singular matrix. Okay, so since you are following this YouTube channel, I'm going to give you some things that you can know. I cannot even stand, I'm just dancing. Okay, if in this equation A inverse, first we will check about A inverse, then we will go to those extra concepts that I was about to say. A inverse is equal to 1 by determinant of A. That means A inverse is going to be a matrix only. First A is going to be a matrix only, and from that matrix you will be finding A inverse matrix. Okay, A inverse matrix. From A matrix you will be finding A inverse matrix, and this is what A matrix is. From this you are going to find the A inverse matrix. So you know this is what A matrix is. So you also know how to find the determinant of A matrix. I have just now said how to find determinant of matrix some hours before. Okay, so that into adjoint of A. That also I have just now said. Okay, how to find adjoint of A, all those things as shortcut tricks, all those I have just now said. So this is what A matrix is. Very simple, right? If you understand all these concepts, they are very simple to me. Okay, so now coming to this concept. Okay, now coming to that concept. If determinant of A, that means if A is non-singular. Okay, that means if A matrix is non-singular, that means this X, this Y, and this Z, these three variables can have infinite solutions. Infinite solutions. Then after this, if A is singular, that means if determinant is equal to 0, then that means you will be having two different options. So what are they going to be? First is if adjoint of A and into B, that means this matrix and this adjoint of this matrix is, if you are multiplying these two matrices, then it is going to be if it is equal to 0, then it has infinite solutions. Sorry, here it has unique solution. Here it has unique solution. Here it has infinite solution. Okay, here it has infinite solution. And if it is not equal to 0, that means if adjoint of A into B, okay, into B is not equal to 0, then that means it has no solution. Okay, just remember this. Then it has no solution. That's it. Only with last numerical we are going to complete this total determinant topic itself. There are some sums, okay, that we have to discuss, but I'm pretty sure that you all can do those. Very simple sums. Okay, so with last sum I'm going to end this total chapter. x plus 2y is equal to 2. If you can completely understand this concept, then you need not to listen to this sum. If you cannot understand that one, then just listen to this 2 by 2 matrix sum. We will complete this. Is equal to 2, and also next is going to be 2x plus 3y is equal to 3. Okay, so this is what this equation is. These two equations have been given. Now what you are going to do is we are going to create those matrices. So first I'm going to take the constants. What are constant here? 1 will be the constant, here 2 is the constant, here 2, here 3 is the constant. 1, 2, 2 and 3. I will write it in different color. A matrix. Okay, this is what A matrix is. 1, 2, 2, 3. Okay, and then B matrix is going to be X and Y, since only two variables are there. So it's going to be just X and Y. And then sorry, this is not B, this is X. Then B is equal to 2, 3. Okay, then B is equal to 2 and 3. Now you have got these, and you can put it in this formula. So that means I've got A. Okay, I've got X and I've got B. But in this formula, B we have, X we have, but A inverse we don't have. So you have to find A inverse. A inverse is equal to determinant of A into adjoint of A. So what is determinant of A? Determinant of A is 3 minus 4, which is equal to minus 1. 3 minus 4 is equal to minus 1. This minus this. Okay. Then after this, adjoint of A is going to be, it is a matrix only. Adjoint of A is a matrix. This we know. Which is, see, this and this has to swap their places. So 3 and 1 will come here. These two should be actually having the signs interchanged. So it will be minus 2. Here also it will be minus 2. So you have to multiply this minus 1. That means now substitute in these two values in this equation. It's going to be 1 by minus 1 into 3 minus 2 into 1. So which is, so multiply, if you are multiplying this minus 1 here, since it is 1 by minus 1 is equal to minus 1, so if you are multiplying it here, minus 3, 2, 2 and minus 1. Now we have got the A inverse also. Okay, so now we have got the A inverse also. Now what we are going to do, now we are going to find the X. So X is equal to A inverse into B. X is equal to, now what is A inverse? A inverse is minus 3, 2, 2, minus 1 into B. So what is B? It is 2, 3. Okay, now we are going to multiply this. 2 into 2, 2 into 1. Okay, so this like this. So minus 3 and then 2, which is minus 6. 2 into 3, so that will be plus 6. Okay, now this and then this, which is going to be 4 minus 3. 4 minus 3, which is 2 into 1, which means, see, this is actually something you would have already known. In matrix, we'll be seeing all these multiplications at all very cleanly. But I'll be just saying that if this value and if this value is same, then we can multiply. And if this value and this value is same, and the resulting matrix will be having the order of this value and this value. Okay, so it's going to be 0 and 1. It's going to be 0 and 1 or plus 1, both are same only. Nah? You will not write 1 as plus 1 always. Okay, so I've got the X. So what is the X? X is this one. So X, Y is equal to 0 plus 1, which is X is equal to 0, Y is equal to plus 1. So we have completed the total determinant itself. Well, it's not completely very in depth, but have said every concept in a level. If you cannot understand a concept, then you can comment me down. If I have time, I will try to upload that video, or I will message you back in comment section. Bye bye.